So I'm just going to give you a brief demonstration of automation playback. So the scenario here is that I've been sent some files that have been recorded on a machine that has exhibited an error. So the servos on the machine have stopped abruptly. So the maintenance engineer sent me all the files provided by Automation Playback for review. One of the files that's sent to me is a complete backup of the controller. So I get an exact copy of the application code running in the machine for my analysis. So this is what you're seeing here. This is the code that I've been sent. So if we firstly just review how Automation Playback is set up, there's a little button here specifically for Automation Playback in the controller settings. And there's essentially three sections that can be set up. The first section, the common settings, is where we enable the Automation Playback functionality within your machine. And then we've got two sets of parameters here. So we can have two ways in which Automation Playback works within the machine environment. And we can switch those using application code within the machine. So here we're going to be working with sample settings 1. We'll look at those in a moment. This is the button that the maintenance engineer set up previously so that I get a complete backup of the project of the machine, so I can see the application code running currently on the machine. We have a couple of options here to ensure that we've got space on the SD card that's inserted in the controller, so that we can ensure that we've got enough space on that card to record the application playback data at a later point. Let's have a look at the sample settings themselves. So this is more the area where we set up how Automation Playback will operate, which mode of operation, and the trigger that will actually start Automation Playback for us. So here at the top, we give the sample settings a simple name, and included in the Automation Playback, we've asked the controller to record some axis variables. So these are the servo axes. We can pick up the position and the velocity of the servo on every scan of the controller, thousands of times a second. And down here are all the programs or the POUs that are within the application, which are echoed here within the project. So we can even decide which parts of the program we want to record with Automation Playback to really refine down to particular programs that we want to look at issues. And the final part is the trigger. So I just click here. You can see that we've a variable here, a variable within the program that we want to use to trigger Automation Playback when there is an error on the production line. Now there's two modes of operation with Automation Playback. Pre and post trigger method. This is where the trigger will initiate a recording post trigger sampling, but we will already be recording data prior to the trigger point. And we can set up time before and after the trigger point that we want to record this data. Now with Automation Playback, we have up to 15 minutes worth of data recording in total. So in essence, we could have 7.5 minutes before and 7.5 minutes after the trigger point is enabled. Another method of Automation Playback is what we call start save trigger method. This is where we introduce a second trigger, which will start Automation Playback recording data. And we set a time that we want that Automation Playback data to be recorded for. Once it's complete, we have the original trigger point, which will decide within our application whether we want to record that data. So this method of Automation Playback could be used on a part-by-part basis, recording information about a part and deciding whether it's a good or a bad part at the end of that production cycle, and decide whether to record that data. Okay, so now we have a look at the setup of Automation Playback. Let's look at Automation Playback itself. So I'm just opening up Automation Playback mode within Sysmax Studio. Now I can go and select those files that we spoke about earlier. So I'm going to go and retrieve from my desktop and the bin file that the maintenance engineer sent me relating to the error on a part or the stoppage of a machine. I can now record, as we have the possibility of recording data from CCTV video cameras located around the machine, and we've got the option of up to 4 different video feeds that we can import into the project. So I'm going to import CCTV video from a bad part, and it's in a MKV video format. Let's start the playback. So just to remind you, we're now dealing with data that has come from a working machine that had an issue, and Automation Playback has captured the data from the machine so that we can review it in real time now. So the first thing you'll see is a video image coming from the machine. I'll just move that over here. And we have an iPhone on front of the demo case here, just to give you the real-time video signature, if you like. Here we have the playback control. So from here, if I press the start button, you'll start seeing things happening on the video file, and you'll also see corresponding changes here within the application, again in real time. If we look at the right-hand side here, we've got a timestamp coming from the video and a cycle or scan count coming from the Automation Playback data. And we can go back by single scans. You can see the scan number here going down by 1. We can go back through the video file or forward by 1 single scan if we want to. This bar here in front of the red line is our 30 seconds that we set up pre-trigger, and the bar to the right of that is the 5 seconds we set up for post-trigger. And the trigger point itself is represented by this red line. You can imagine if we have 15 minutes worth of data, we can change the play rate up to 8 times here to enable us to review the data quickly through that 15 minutes worth of data captured. And this button here will take us to the final trigger point, and we can scroll through what's going on in the machine, and you'll see that the video and the application data changes as we scroll. Another tool we have is our graphical playback chart. And with this, we can pick items of data from our application. So for instance, this move relative command, which will move the servo motor a relative distance, we can drag and drop that into our chart, and it will show us the data for the full sample period of this bit or this Boolean going on and off within the data. We can also add variables directly. So I mentioned earlier that we can add in data around the servo itself. So the axis that we have in the image is called wheel. We can pick up the actual position of the wheel and add that to our data graph for analysis. We can even add the velocity of the wheel into our data analysis. So now you will see a review of exactly what happened on the machine with the servo, if I can size the window. So let me scroll down here. So if we look at the move here, we can see a nice acceleration, deceleration, acceleration, deceleration profile. But now we can see the abrupt stop that was reported by the maintenance engineer, where we've accelerated our servo, travel at a constant speed, and immediately stop. If we want to find out where that happened in our time, we've got a little cursor here that we can move to a particular point and work out instantaneous values at that point. So the velocity is at 0 here, and the position of the axis at the time of the error was 11129. We can also do this analytically using the fourth tool in Automation Playback, which is the search playback data. So in this instance, we could look for the point in the process where we reach this position of 11129. So I'm just going to add in the wheel actual position again, and we're going to try and find within the data the point where we reached that position where the error occurred, 11129. So now if we look at the bottom of the screen here, we can see all the instances where we reached that position, and this is the very point in our logged data where we reached that position. So if we double click on this point, Automation Playback will take us to that point in the variables, in the application, and also in the video. And you notice here now that in the video we've got some error lights coming on, within the video playback. So this is giving us some context information about the application. If we move through a few frames of the automation playback, we also see within the application that the power to the wheel has now been removed, indicated by this green conduction line, if you like, through the function block. So the function block has gone into fault. So now we can start delving into our code and find out the true cause of the fault. Or in this case, we can review the video and we can see that someone here has removed the communications cable to the drive, putting it into error, and then reset the machine. So it's obvious from the video file what's happened within this instance. And now the drive has repowered, now that the error has been reset by the operator. Another key feature of automation playback is that we can import the golden part, the part where there is no error, and overlay it onto our error part that we're showing here, which is called comparison in automation playback. So very much like before, I can go into the files that the maintenance engineer sent me and pick up those golden parts in parameter files and also in video files. So now we have two images within our video playback tool, the bad part and the good part. And we have in the graphical playback, the playback chart, we can see the original bad part in this blue turquoise color. And the good part is being overlaid with a gray trace in the background. So you can notice in the original part, there's more moves in the gray trace than there is in the blue. But we can align the data in time for analysis. So here in the bad part, we had 1, 2, 3, 4, 5 moves where the error occurred. So we can align with the alignment tool the fifth occurrence of a move for both the traces using the variable B move relative, which is the variable in the application that initiates those moves. Align the data. And now we can see that the fifth move has been aligned in time using automation playback, where we have the error part and the perfect part continuing with 3 more moves. So hopefully that gives you an insight into the capability briefly of automation playback. Thank you, everybody. Bye-bye.